Patel, and today we will be going over proton or mass spec IR, proton NMR, and carbon NMR of the molecule CH8O3.
Hi, I'm Alvaro Bufole from University of Illinois Springfield, and I'll be helping my partner go over these four methods to figure out the structure of CH8H8O3. To begin, let's start with the mass spec. First, we know our formula is C8H8O3, so you can figure out the degrees of unsaturation. Just figure out by doing 2 times 8 plus 2. 2 times 8 represent the 8 carbons plus 2 minus 8 to represent the 8 hydrogens, and divide which equals 10, and we divide that by 2, which equals 5. So from that we know we have possibly one double bond at least, or perhaps one benzene ring, which would solve the 4 portion of the DOU. 4 plus 1 equals 5. So that's now we're going on to our mass spec. We know our molecular mass is 152. We can figure out that here. We know our base peak is around here, which is here around 120, I believe. You could try to figure out some possible fragments: 32, 60, 27, 26. We don't seem to be finding much fragments that say match up with this table, so I'd say this possibly isn't very useful for us. Now we can move on to IR. In zone 1, we see a very big dip here, which is possible sign of an OH group between zone 1 and 2. In zone 2, we see a very distinct line down here, which is passed to the right of the 3000 range. So that tells us we have a possible sp3 bond. Zone 3, we have nothing. Zone 4, we see a very sharp sword like strike down in the IR spectrum. So that tells us we definitely have a C-double-O. In zone 5, we see 2 distinct spikes over here, which tells us we have some sort of benzene ring within our molecule, which would, I say, align with what we have with our DOU. And here we see some sort of, in the fingerprint region, we see some sort of lines that say represents the C, some sort of ester stretch, C to the CO bond ester stretch. So now after we have information gathered from the IR spectrum, we can try to figure out the structure of a molecule in the HNMR, which my part would do.
Okay, so the first thing you want to do is have a structure drawn out which you think could be it. And so we have the 8 carbons, 1, 2, 3, 4, 5, 6, 7, and 8. And then the 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, and 8. And then the 3 oxygens, which are 1, 2, and 3 right there. So the next thing you want to do is look at the integration of the molecule, or of the structure. So when we start with this carbon, we have the integration of however many carbons are attached to it and however many hydrogens are on there. So for this carbon, there's no other carbons attached to it, so the integration of it is just n plus 1, which is 0 plus 1. So the integration is 1. Then for the next one, we have this carbon over, or this hydrogen over here, and it's not attached to any carbon, so its integration is 0 or 1. And we see this, and it's a singlet. These 4 are part of the benzene ring.
You can't always tell because even if they're singles, they're different sizes.
And this is of the OH group. So when
So you can get to your 7. Yeah.
we look at this carbon right here, and it has 3 hydrogens attached, which make it pair up with this singlet, because it has the integration of 3 up there written. Next, you want to look at these 4 hydrogens down here, and they're all within the same center because they're attached to the same benzene ring. So these four correspond to these four hydrogen atoms, and then for the last one all the way at 10.7, we have the last OH, and it's all the way over here because of the shielding, because of the OH. So then we want to go to the carbon NMR, and we want to draw the structure again, and then we want to label all of these signals down here, and we know deshielding. We know that deshielding goes this way, so the most deshielded would be all the way over here. So we look, and the double bonded oxygen to the carbon is the most deshielded, so that'd be 8. And the ester, or wait, the other oxygen that's attached to this carbon would be 7, because it's the second most deshielded, so it's all the way to the left. And then we'd go to the benzene rings. So the benzene rings, they could be in any order. You don't really know, but so we had it as 5 or 6, 5. We had this as 6, 5, 4, 3, and 2. And then as our least deshielded carbon, we had this one that's CH3, which is a tertiary alkyl group. So this first one falls under the tertiary alkyl. The 2, 3, 4, 5, and 6 fall into the aromatic region, and the 8 falls into the ester region. And that's the structure we got, and that has been the mass spec IR, proton NMR, and carbon NMR of CH8O3.